Hi everyone, my name is Zulaikha Batrisya binti Azhari and my Matric number is 228520. Today I'll be presenting my individual assignment for CCS 4500, which is Computer Security. My presentation title is Blockchain for Academic Credentials and Non-Cryptocurrency Security Applications. So for my use case, I've chosen the education domain with the focus being specifically on academic credentials, which is things like your degree certificates, diplomas, and transcripts. So now let's get into it. So, first, why does this even matter? Think about it this way. When you graduate and apply for a job, your employer needs to verify that your degree is real. And right now, that process is honestly kind of mess. Credential fraud is growing global concern. Employers often can't officially verify whether a certificate is genuine or not. On top of that, physical paper degrees can be lost, damaged, or even forged. Calling university to manually verify that's slow and inefficient, especially if it's an overseas institutions. So these are the real problems that exist right now. Now, why is blockchain being considered as the solution here? Because blockchain has some really unique properties. Once a degree is stored on blockchain, it cannot be altered or deleted ever. Anyone, whether it's an employer or another university, can verify a credential instantly without needing to call anyone, and there is no single central database to hack, and every credential comes with a cryptographic proof of authenticity, so you will know it's real. And I want to be very clear, this is non-cryptocurrency applications. We're not talking about Bitcoin or any digital currency here. We are purely using blockchain as a secure, decentralized database for academic records. What actually gets stored inside each block for this use case? I've divided each block into three main sections. The first section is the block header. This is basically the metadata of the block. It contains the block index, which tells you where this block sits in the chain. Then there's the timestamp, recording exactly when the credential was issued. We also have the previous hash. This is super important because it's what links this block to the one before it. The current hash is this block's own unique fingerprint. And finally, the Merkle roots, which is a combined hash of all credentials stored in that block. So the second section is the credential data. This is where the actual academic information lives. You've got the student ID, this example that's A228520, the credential type, which is Bachelor of Computer Science, the institution, University of Malaysia, the data issued, and the digital signature, which is a cryptographic proof that only the issuing institution can create, so you will know it's legit. The third section is the hash pointer, and this simply points forward to the next block in the chain, so everything will stay connected. And on the right side of the slide, you can see the table explaining why each field exists. Every single field has a purpose, nothing is here just for decoration. The hashes will ensure tamper detection, digital signature proves authenticity, and the chain linkage means you physically cannot modify one block without breaking the entire chain. Now, let's compare what is the actual difference between storing academic credentials on a traditional databases versus on a blockchain. So if you look at the table, I've broken it down across six key aspects. Starting with data integrity, in a traditional database, an admin could technically go in and change a record. But in blockchain, once it's recorded, it's immutable. It cannot be changed. For access control, traditional databases are centralized, meaning one authority controls everything. Blockchain is decentralized, where all nodes in the network verify every transaction. For transparency, traditional databases are hidden from the public, but blockchain is transparent and fully auditable. Next is tamper resistance, where traditional databases are vulnerable to insider attacks. Blockchain uses cryptographic hashing, so any attempt to tamper is instantly detected. Next is verification speed. Instead of calling a university and waiting days for a response, blockchain will allow instant verification by anyone and anywhere. And finally, something I think is really important is credential portability. In a traditional system, your records are locked to one institution database. But with blockchain, you as the learner own and carry your records across institutions. You're not dependent on any third party to validate your credentials. So overall, for academic credentials specifically, blockchain is most suitable because it eliminates the over-reliance on a single system that could be hacked, corrupted, or manipulated. And academic credentials require high trust and integrity, which protects against the forgery. Okay, moving on, let's talk about threats, specifically a credential forgery. So, without blockchain, here's what can happen. A bad actor can create a fake degree certificate that looks completely legit. Employers have no quick way to verify it. University database can be hacked and records silently altered. And physical certifications, they can be duplicated fairly easily. And this is the real problem, and it has real consequences for employers who hire unqualified people and for legitimate graduates whose value gets undermined. Now, how does blockchain specifically protect against these threats? First, immutability. Once a credential is recorded on the blockchain, it cannot change, period. Second, cryptographic hashing. If anyone tries to alter even a single character, the hash of that block changes completely, and the entire chain breaks and will instantly detectable. Third is decentralization. There is no single point to attack. An attacker will need to control the majority of all nodes simultaneously, which is extremely difficult. Fourth is digital signature. Only the official issuing institution can sign and create a credential. You cannot fit that. Fifth is consensus mechanism. All nodes must agree before any record is added. So even if one node is compromised, the rest will reject the fraudulent data. And lastly, something from recent research, which is self-sovereign identity. This means students themselves own and control their digital credentials without relying on any central authority to validate them. Now, let's talk about the consensus mechanism, specifically why proof of work is not suitable for this use case and what I'm proposing instead. So, proof of work, which is what Bitcoin uses, requires massive computational power to solve complex mathematical puzzles. Universities are not cryptocurrency miners. Credentials are issued maybe once or twice a year per student, not thousands of times per second. So, proof of work is way too slow, way too energy intensive, and it's simply not designed for a trusted institutional network like this. Next, my proposed alternative is proof of authority or POA. Under POA, only known and trusted validators are allowed to add records to the blockchain. In this context, that means universities, the Malaysian Qualifications Agency, and the Ministry of Education. These are pre-approved, accountable institutions. Where transactions are fast, no complex puzzle to solve, it's energy efficient, no mining hardware required, it's perfect for a consortium of Malaysian universities working together. And as highlighted by Alsobi and College in their 2023 Systematic Literature Review, proof of authority directly addresses the scalability challenges that have been identified as a key barrier to blockchain adoption in higher education. So if you look at the comparison table, you can see clearly across every single criteria, proof of authority wins for this use case. So to wrap up, blockchain technology when applied to academic credentials will solve real existing problems around fraud, verification delays, and data integrity in a way that traditional database simply cannot match. So thank you so much for listening. I really hope this explanation was clear and easy to follow. Thank you.